Hello students, and you are welcome back to Solve Your Mathematics Past Question class. Today we continue on the aspect of matrices in today's class. We'll be solving our question from our West African Examination Council past question. We're solving our question across the year 2000 to 2010. So the first question I have here with me is from the Y past question 2005. It says, given the matrices G to be in rows, into brackets 1, 3, 2, 4, close bracket, and H to be, calling my figures in rows, into brackets 2, 1, then 0, 3, then close bracket. Find G plus H. So to find G plus H means we're going to add the matrix of G to our matrix of H. So now let's write out our matrix of G, calling my figures in rows. So into bracket 1, 3, 2, 4, close bracket, plus in rows of matrix H, 2, 1, then 0, 3, close bracket. So how do we solve this? It's very simple. We add the rows of G to the columns of H, and the second rows of G to the columns of H. So let's go about it. So calling my figures in rows now. So we have 1 plus 2 and 3 plus 1. Then the second row should be 2 plus 0, then 4 plus 3, close bracket. When we add these figures together, now let's look at it in row. The first row, we have 1 plus 2, so that will be 3. Under the figure of the first row, we have 3 plus 1, and that will be 4. Then the second row, we have 2 plus 0, and that will be 2. And we are under the second row, we have 4 plus 3, that will be 7. So matrix G plus H will give us 3, 4, then 2, 7, close bracket. The next question we have here is from the Y past question 2006. It says, find the determinant of the matrix I, which is equals to, into brackets, calling my figures in rows, so that will be 5, 1, 2, 3, then close bracket. So to find the determinant of I, so we multiply the numbers in diagonal and we minus them from each other. So that will be 5 times 3 minus 2 times 1, then close bracket. So we have 15 minus 2, and that will be 13 as our final answer. So that's the determinant of the matrix. The next question we have here is from the Y past question 2007. It says, for the matrix J, which is equals to, calling my figures in rows, into bracket 4, 2, 3, 1, close bracket, find the scalar multiplication of J by 3. So that means we multiply 3 with the matrix of J. So all we have to do is to multiply each figures either in rows or column by 3. So we have 3J to be 3 into bracket 4, 2, 3, 1, then close bracket. So multiplying each number by 3. So we then have 3J to be, which is our final answer, to be 12, 6, then 9, 3, close bracket as our final answer. The next question we have here is from the Y past question 2008. It said, given the matrix K, which is into bracket, calling my figures in rows, to be 6, 3, then 1, 2, close bracket, then find the inverse of K. That is K raised to the power minus 1. So to determine the inverse of K, we have to find the determinant of K first. And to get the determinant of K, meaning we have to multiply our figures in diagonals and minus them from each other. So we have 6 times 2 minus into bracket 1 times 3. So we have 6 times 2, that will be 12, then 1 times 3, that will be 3. So 12 minus 3, that will be 9. So 9 is the determinant of K. So to get the inverse of K, which is K raised to the power minus 1, that will be 1 all over that determinant of K. So that will be 1 over determinant of K into bracket the inverse of K, which is now into brackets 2 minus 3, then minus 1, then 6, close bracket. So when we put all these figures together, then we'll be having 1 over 9, because 9 is the determinant. So 1 over 9 into bracket 2 minus 3, calling my figures in rows, then minus 1, then 6, close bracket. We multiply each figures with 1 over 9. So that'll be, looking at the first row, so we have 1 over 9 times 2, then 1 over 9 times minus 3, and we have 1 over 9 times minus 1, and we have 1 over 9 times 6. When we multiply this together and divide through, we'll be having, calling my figures in rows, so we have 2 over 9, then minus 1 over 3, then to the second rows we have minus 1 over 9 and 2 over 3 as our final answer. So the last question we'll be looking at today is from the Y past question 2009. Say, find the product of matrices L, into brackets, calling my figures in rows. So we have 2, 1, 3, 4, close bracket, that's 2 by 2 matrix, and M into brackets 2 by 2 matrix, we have 0, 1, 1, 0, close bracket. So to find the product of LM, So we have to put the two matrices beside each other. So that would be LM to be equals to, calling my figures in row, which is by 2 matrix, into brackets 2, 1, 3, 4, close bracket, and into bracket 0, 1, 1, 0, close bracket. So all we have to do is to multiply the rows of L to the columns of M, and second rows of L to the columns of M. So we have into bracket 2 times 0 plus 3 times 1 close bracket. Then the next under the first row will be 1 times 0 plus 4 times 1 close bracket. Then we move to the second row to be 2 times 1 plus 3 times 0. And under the second row we have 1 times 1 plus 4 times 0 close bracket. When we multiply this together, we'll be having these figures to be in rows. That will be 3, 4, then 2, 1. So LM equals to 3, 4, 2, 1. That's by 2 matrix. So this is where we are going to stop for today's class. We hope with what we have been able to show you and explain it this class, we've been able to better your understanding on the concept of matrices. Stay with us as concerning this same topic in our next class, where we look at introduction in matrices and addition and subtraction. Thank you and bye for now.